The 20th century witnessed a scientific revolution, the discovery of nuclear energy. Scientists learned to split the atom, releasing immense power. This breakthrough held the promise of clean energy and also the threat of unprecedented destruction. Early pioneers, driven by curiosity and national ambitions, embarked on a journey that would change the world forever. The discovery of radioactivity by Henri Becquerel in 1896 paved the way for understanding the atom's hidden energy. Marie Curie's groundbreaking research on radium and polonium further illuminated the nature of radioactive decay. These discoveries laid the foundation for the later development of nuclear weapons. In 1938, German scientists Otto Hahn and Fritz Strassmann achieved nuclear fission, splitting a uranium atom. This breakthrough sent shockwaves through the scientific community. The potential energy released was enormous, and the implications for both peace and war were immediately apparent. Physicists worldwide understood the implications of nuclear fission. The possibility of a weapon with unimaginable destructive power loomed large. World War II was about to begin, and this new discovery would soon play a decisive role in the conflict. With the outbreak of World War II, the race to harness the atom's power intensified. The United States launched the Manhattan Project in 1939. This top-secret program brought together the brightest minds, led by General Leslie Groves and physicist J. Robert Oppenheimer. The project culminated in the successful test of the first atomic bomb on July 16, 1945. The explosion marked the beginning of the atomic age, forever changing history. The Trinity test was the culmination of years of intense research and development. In the desolate landscape of New Mexico, scientists and engineers prepared for the first ever detonation of an atomic bomb. The atmosphere was tense with anticipation and uncertainty. At 5:29 a.m. on July 16, 1945, the world's first nuclear explosion lit up the New Mexico desert. The blinding flash was followed by a deafening roar and a mushroom cloud that rose miles into the sky. The test was a success, but it came with a heavy price. The Trinity test marked the dawn of the atomic age. The immense power unleashed that day brought about a new era of potential destruction. The world could no longer ignore the devastating consequences of this new weapon. The test also raised profound moral and ethical questions. The scientists who had worked on the Manhattan Project were confronted with the devastating power they had unleashed. The world had entered a new and uncertain age. Just weeks after the Trinity test, the United States made the fateful decision to use atomic bombs against Japan. The cities of Hiroshima and Nagasaki were chosen as targets, and on August 6 and 9, 1945, the world witnessed the horrors of nuclear warfare. The bombs, nicknamed Little Boy and Fat Man, instantly killed tens of thousands of people in Hiroshima and Nagasaki. The blasts obliterated buildings, ignited firestorms, and left behind a radioactive wasteland. The human suffering was unimaginable. The immediate aftermath of the bombings was catastrophic, but the long-term effects were equally devastating. Thousands more died from radiation sickness, and generations suffered from cancers and other illnesses linked to the bombings. The use of atomic bombs on Hiroshima and Nagasaki remains a controversial topic. While some argue that the bombings were necessary to end the war, others condemn them as inhumane acts of terror. The debate continues to shape our understanding of the ethical and moral implications of nuclear weapons. The bombings of Hiroshima and Nagasaki ushered in a new era of global politics, the atomic age. The world now lived in the shadow of mutually assured destruction, or MAD, where the use of nuclear weapons by one nation would inevitably lead to retaliation and global annihilation. The Cold War between the United States and the Soviet Union saw a dangerous nuclear arms race. Both superpowers amassed vast arsenals of nuclear weapons, each capable of destroying the other many times over. The world held its breath, knowing that any miscalculation could lead to global catastrophe. The Cuban Missile Crisis of 1962 brought the world to the brink of nuclear war. The discovery of Soviet missiles in Cuba, just 90 miles from U.S. soil, sparked a tense standoff between the two superpowers. For 13 days, the world watched in fear as diplomacy averted disaster. The Cuban Missile Crisis served as a stark reminder of the fragility of peace in the nuclear age. It underscored the need for dialogue, diplomacy, and arms control to prevent a nuclear holocaust. The Cold War arms race led to an unprecedented increase in the number and destructive power of nuclear weapons. Both the US and the Soviet Union developed increasingly sophisticated and deadly arsenals, including intercontinental ballistic missiles, or ICBMs, capable of striking targets thousands of miles away. The proliferation of nuclear weapons to other countries further heightened global anxieties. The United Kingdom, France, China, India, Pakistan, Israel, and North Korea all developed nuclear weapons, raising concerns about regional conflicts escalating into nuclear confrontations. The dangers of nuclear proliferation extend beyond the risk of intentional use. Accidents, miscalculations, and the potential for nuclear materials to fall into the wrong hands pose significant threats to global security. The Chernobyl disaster of 1986 serves as a stark reminder of the catastrophic consequences of nuclear accidents. Despite some progress in nuclear disarmament, thousands of nuclear weapons remain in existence today. The risk of nuclear war, whether intentional or accidental, continues to cast a long shadow over humanity. The development and proliferation of nuclear weapons led to a dangerous era of nuclear testing. From the 1940s through the 1990s, thousands of nuclear tests were conducted, primarily by the US and the Soviet Union, releasing massive amounts of radiation into the environment. These tests had devastating consequences for both human health and the environment. People living near test sites, as well as military personnel involved in the tests, were exposed to dangerous levels of radiation, leading to increased rates of cancer, birth defects, and other health problems. The environmental damage caused by nuclear testing is widespread and long-lasting. Radioactive fallout from the tests contaminated soil, water, and air, posing significant risks to ecosystems and human health. The long-term effects of this contamination continue to be felt today. The Comprehensive Test Ban Treaty, CTBT, adopted by the United Nations in 1996, aims to ban all nuclear explosions. While the treaty has not yet entered into force, it represents a significant step towards ending the harmful legacy of nuclear testing. The invention and use of nuclear weapons had a profound impact on societies worldwide. The constant threat of nuclear annihilation shaped political discourse, influenced popular culture, and fueled anxieties about the future. The Cold War saw widespread fear of nuclear attack, leading to the construction of bomb shelters, duck and cover drills in schools, and a pervasive sense of unease. The threat of nuclear war permeated every aspect of life, from international relations to everyday conversations. Nuclear weapons have also had a significant impact on popular culture. Movies, books, and music reflected the anxieties and fears of the nuclear age, exploring themes of apocalypse, survival, and the moral implications of such destructive power. The legacy of nuclear weapons continues to shape our world today. The threat of nuclear terrorism, the ongoing challenges of non-proliferation, and the need to secure nuclear materials all demand international cooperation and vigilance. The horrors of Hiroshima and Nagasaki, and the threat of Cold War annihilation, spurred efforts to prevent nuclear spread. The NPT, in force since 1970, aims to prevent nuclear spread and promote disarmament. The IEA monitors compliance and promotes safe nuclear use. Despite efforts, nuclear non-proliferation challenges remain. As we navigate the 21st century, the future of nuclear weapons remains uncertain. The world faces a complex and evolving landscape of nuclear threats, including the potential for new arms races, the rise of non-state actors, and the dangers of accidental or unauthorized use. Technological advancements such as cyber warfare and artificial intelligence introduce new challenges to nuclear security. The potential for these technologies to be used to disrupt command and control systems or compromise the security of nuclear arsenals raises serious concerns about the risk of miscalculation or escalation. Despite these challenges, there are also glimmers of hope. The New START treaty between the US and Russia, which entered into force in 2011, represents a commitment to reducing nuclear arsenals. Civil society organizations and individuals around the world continue to advocate for disarmament and raise awareness about the humanitarian consequences of nuclear war. Ultimately, achieving a world free of nuclear weapons will require sustained international cooperation, political will, and a shared understanding of the existential threat they pose to humanity. The future of our planet may depend on our ability to meet this challenge.